Okay, next we're going to actually show us how to actually do this in SPSS. We'd actually arrange it just like we did the independent sample t-test. Column 1 would be condition, you might call it. You can make the first three numbers 1, the second three numbers 2. That's the independent variable levels. The second column, memory scores, 5, 6, and 7, 1, 2, and 3. So if we go and do the analysis, we go into Analyze, and now under Compare Means, notice what the bottom one says. One-way ANOVA. And you put for the dependent variable, which would it be? Memory scores, and condition is the other one. And then you can just, actually, let's just do the OK on that. And if you do it, you get the bottom screen. I think I printed it out. You could do more than that. But that's what you get. Look at the very bottom, or the memory score ANOVA screen. Notice what it did there. This thing. This is that. So we're looking at the table, the second table, memory scores. And the idea is, between groups, sums of squares is what there?
24.
And did we figure out how we got that?
Yes.
Yeah. Do we want that number to be large or small?
Large.
Large. That reflects treatment effect. What were the degrees of freedom between groups?
That was 4.
Well, the degrees of freedom between groups
was 1.
was 1.
Yeah.
So we got here 1, and then the mean square, which is another way of saying variance, is 24. 24 over 1 is 24. Within groups, sums of squares was 4, because 3 consecutive numbers twice. 4 there, we want that number to be what?
Small.
Small. Degrees of freedom, 4. Mean square, which is another term for variance, is 1. So the important thing to note here is for the mean squares, we want the numerator for the mean square to be large. That's treatment effect. The denominator to be small. And when we put 24 over 1, what is our F obtained score?
24.
24. What is the probability of getting an F score of 24?
0.8%? 0.08%.
0.08, yeah, it's 0.8, yeah, 0.08%, or less than, yeah. So the way we would write this out, and let me give you the final bit on that, it actually says it on the line below. You see it on the line right below there, the F. I wrote it out. F,
Oh, right there.
F, and then it has degrees of freedom numerator, F of 1, 4 for the denominator, equals 24, P equals 0.008. This result is statistically significant.
Some of the new drug helps.
The drug does help with memory. So this is indeed good news. The last thing I'd like you to do with this is go back to your data set and actually do Analyze. What I'd like you to run is an independent sample t-test on this. Go to Compare Means, do an independent sample t-test. Got to X out of that.
Oh, X out of that?
Yep, X out of that one. Do Analyze and Compare Means and independent sample t-test, and put in the DV as memory score and condition, and then define the groups 1 and 2 and do continue. And when you run it, what was your T obtained score?
I've got the independent sample table is not produced.
Uh-oh, I must have not done something right. Go back to it.
Here.
Test.
Yeah.
Nope, you put a 1 and 3 in there. Oh, did you? You did.
I wouldn't spread it. Sure did.
2 is better.
That'll work.
That's okay.
Got it.
And notice what it did here. What was your T obtained score?
It's a 4.899.
And notice what the sig is.
It's 1 or 0.008.
0.008, the same as the other. There's a very important relationship here. Do you notice any relationship between your T score and your F score? What was your F score for the same problem?
Same thing, yeah.
What was your F score?
Oh, the F score was 24.
So what was your T score?
4.89.
You notice any relationship between those two?
It's the addition, or the subtraction. No, I don't actually. No.
When you do ANOVAs, what do we do with everything in ANOVAs? What do we we square it.
Okay.
So guess what happens if you take your calculator and put 4.899 and square it?
It's pretty close to 24.
It is 24.
What is 24?
T squared equals F.
Right.
We can do a t-test on this. But T squared equals F. So we've proven something very important here. What I would like you to do for homework, and the rest of the class as well, is I'd like you to do the same data example, and I'd like you to do this by hand, but instead of having, 1, 2, 3, and 5, 6, 7, I'd like you to change the drug condition to 2, 3, and 4. Change it to 2, 3, and 4. When people got the drug, the recall was 2, 3, and 4. And see if you can do that out by hand. You can probably guess what it's going to be, but see if you can do that out by hand and send me drafts of that. Okay.